All right, so we're going to take a look at the non-calculator section. So evaluate linear functions. All that means is that in place of, it says g of x, so you see here, x, it says find g of 3. That means where you see x, right, I'm going to put 3. So I take this function right here, okay, and where I see x, I'm going to put 3. So I put 3. What does that do for my equation? Like, how do I evaluate that? I've got negative 5 times 3, which is negative 15. Negative 15 plus 1. So I've got negative 15 plus 1. Okay, so I've got negatives. I'm meeting positives. What's going to happen? They're going to fight. Who's going to win? Negatives are going to win by 14. So all evaluate a function means is in place of that x, you're going to put in whatever they give you. Okay, in place of it, you're going to put in what they give you, and that's it. Adding and subtracting radicals. Now, I just want to mention real quick on the EOC, right here, they just giving you 2. On the EOC, they will give you 3. So what I'm going to do is I'm actually going to do the 2 for the question, but then I'm going to add 1 so that you can get some practice as to what that looks like. All right, so remember, whenever you have radicals, what you want to do is you're concentrating on making books. So we're going to make books right here. I need to know what goes into 147 without a calculator. So this is where, if you don't know how to do it, you sing my long division song. All right, so I know 2 doesn't go into it. How do I know that? Because this is not an even number right here, right? 2 does not go into it. To check 3, remember for 3, if you add the individual units, if it's divisible by 3, 3 goes into it. So 1 plus 4 is 5. 5 plus 7 is 12. Does 3 go into 12? It does. So 3 goes into 147. All right, so 3 goes into 147. Now, we're going to sing the song, okay? Or rather, I'm going to sing the song, but you're going to definitely listen. All right, first you divide 3 into 14, goes 4 times. Then multiply, so that's 12. Then subtract, that's 2. Hey, bring it down. Okay, so you sang the song once. All right, you're going to sing it again. Now you're coming in here. So first you divide, and it's hard to sing and concentrate at the same time. 3 into 27 is 4. Oh, it's 9. All right, so again, and if you don't know that, you can do this, like this, and keep adding it until you get to what you need to. All right, so first you divide, then multiply, then subtract. Hey, bring it down. There's nothing to bring down, and we're at 0, so we're done. 3 goes into 147 49 times. And you're going to repeat this process until you completely break it down, right? So now I need to know what goes into 49. And I can recognize that 49 is a perfect square, meaning it's 7 times 7, and 7s are both prime, so that's it on breaking it down. 3, I can't break down anymore, so that's completely done. So I'm going to rewrite this with my broken down. Leave a little space because I'm going to be taking books out. I have 3 times 7 times 7, so 3 times 7 times 7, plus 3, and here I just have the 3. All right, so do you see any books? Yes, I see a book of 7, so I'm going to take that outside. Everything is always multiplication. Any books here? No. So 10 times 7 is 70. Here I'm left with 3, and then here I just have 3 radical 3. Now that my radicals are the same, I can add or subtract them. So if this was a subtraction problem, I would do 70 minus 3. But because in addition, I'm doing addition, 70 plus 3, which is going to give me 73. And the radicals just stay the same. So remember, it's just like adding or subtracting x's, or you can think of it as fruit. So this is 70 apples plus 3 apples. How many apples do I have? I have 73 apples. Okay, so remember the radicals, before you can add and subtract, this is the most important thing, they must be the same. And that's why we simplified it first to get them to be the same. Now, in your EOC, you should expect to see one more. So let's say we had minus, I'll do minus 6, radical 18 or something like that. So I'm doing a completely new question basically, but this will be my answer for delta. But I'm just showing you that the process is the same. So let's break this down. What goes into 18? 9 goes into 18 how many times? Twice. So this is a prime number. Break down 9. 3 times 3. Those are both prime. All right, now I'm going to write it up here. So I've got, so it's a minus 6, leave a little space, and then we're breaking down this 18 to 2 times 3 times 3. 2 times 3 times 3. All right, so once that's there, do you see any books? Yep, I see a book of 3. So I'm going to take that outside. So this is here. So here I'm going to have minus 6 times 3, which is 18, radical 2. And unfortunately, when I made this question up, I can't combine that. So I'm actually done. So this answer would be, because I cannot combine it, 73 radical 3 after I combine those two, minus 18 radical 2. So don't think that you're wrong if it's not all one radical. You can only combine radicals if this radicand is the same. Okay, so in the EOC, expect a question like this, okay, where you can get an answer like that. It's fine. That's okay. All right, so my answer was 73 radical 3. All right, we're going to take a look at solving a linear system graphically. Now, again, when you're doing this in a multiple choice situation, it's a little bit different, but I'm going to show it to you from scratch because this is not multiple choice. All right, so graphing this point. Remember, this is mx plus b, right? So this is m, which is the slope, and plus b, which is what? The y-intercept. So you're going to go right to the y-intercept, which is negative 5, and then you're going to do this slope. And this slope says rise 1, run 2. So rise 1, run 2. And that's my graph. All right, on this one, this is not y equals mx plus b. We can do this two ways. I'm going to make it y equals mx plus b by taking this to the other side. So it'll be minus x on the other side. My y-intercept will be 1, so 1. And it'll be minus x. And I can write minus x as negative 1 over 1. So it's going to be down 1, right 1. But I'm going to show that to you on paper, just so that in case you weren't following my voice, it might be a little bit easier to see. So again, I took this to the other side, so it's going to be y equals negative x plus 1. And so here's my y-intercept, which is 1, right? And then over here, I can write this as 1 over 1, because 1 over 1 is still going to be 1. So this is down 1, right 1. All right, the other way that you could do this is by intercept form. So let's see if you remember this. All right, you write the equation out twice. Oh, equals. You write the equation out twice, and then you cross one out. So I'm going to cross y out and solve for the other one. So this is x equals 1. All right, so if I crossed y out, I cross x out. This is y equals 1. And those are your y-intercepts. So x is equal to 1. So I go to the x-axis. It needs to be equal to, why do I have it equal? So I must have graphed this wrong. I'll check it in a second. Oh, because I started at negative 1 instead of what? Positive 1. So that was a mistake. So x equals 1 and y equals 1. So the graph should actually be here. Okay, so I actually graphed that wrong. This is cool that I checked it. So my y-intercept is positive 1, so that's a positive 1. Down 1, right 1. Down 1, right 1. And that would be correct. So two ways that you could do that. Whatever your preference is okay. So negative 1, down 1, right 1. All right, now that that's my graph, what am I supposed to be doing? Solve the systems of equation. All right, solving systems is the intersection. Remember, if I have shades, it's the intersection of shades. But if I don't have shade, it's just that dot right there. So this is 4, negative 3. And how do I put that in? I put it as a coordinate. So this will be 4, comma, negative 3. All right, association correlation by scatter plot. This is really just really simple. You're just looking at the scatter plot and saying what kind of shape and association does it present, right? So if I look at this, I can draw, again, split the dots, right? That's how you do a scatter plot, something like that, right? So automatically this is linear. If the scatter plot looked like this, all right, what does that look like? That looks like a quadratic. So you kind of just split the dots and kind of see what's happening in the shape. Once you know what's happening in the shape, you just, so this is positive linear going up, right? So the scatter plot shows a positive linear. Does it have any outliers? So remember, an outlier is something outside, like completely outside the data set. So it will be a dot right here or a dot over here, just completely outside. All right, that's an outlier. So this one does not have an outlier. So it's a positive linear, all right, because it has plotted values of x increases, the y also increases because it's an increasing graph. All right, difference of perfect squares. We've talked about this in quite at length. Two parentheses, take the square root of the first thing. So what's the square root of 121? 11. So you do it for both, 11. And then you're going to do plus and minus, minus the square root of the second thing. So what's the square root of this? So what's the square root of 100? 100 square rooted is 10, and x squared is x. So this is 10x. So again, it is the square root of the first thing, which is 11, square root of the second thing, which is 10x, plus and minus. That's difference of squares. So what that means is if you can take the difference, so here's a negative, right? Difference of squares. That's why it's called that. Difference of squares. This is how your answer would look. All right, complete the square. All right, so which equation has the same solution? All right, so remember this is my three-step process, right? So you're going to start with the equation. First of all, we need to take the coefficient to the other side. So this is -7 becomes +7 on this side. And then when you write it, leave a space. So remember, you leave a space to set it up, right? So this is 4x. Leave a space equals, I have negatives, I'm meeting positives. Positives, they're going to fight. Positives are going to win by 2. All right, leave another space. So this is squared. Leave another space with parentheses with an equal sign. Now you've set it up for my three-step process. All right, so what's my three-step process again? We're going to divide by 2. So this is going to be +4 divided by 2 is +2. And then we're going to square it. So that's going to be +4. And then remember, you're going to my third step is multiply and apply to the other side. And apply, excuse my handwriting, to the other side. Okay, so multiply, this is an invisible 1 times 4. So this is 1 times 4 is 4. So we're going to do +4. Okay, so this is going to be, I've already completed this side. 2 + 4 is going to be 6. So whatever answer that is. So I'm looking for x + 2 and 6. So this one. All right, so three-step process, set it up by taking the coefficient to the other side, divide by 2, square, multiply, and apply to the other side. All right, three-step process. This is vertex form. We've completed the square. All right, determine if a set of points is a function. So remember, not a function, okay? So remember, for it to be a function, x cannot repeat. So if it's not a function, x must be repeating. So I look at only my x values, 1, 5, 7, and 9. Did any of those repeat? No, this is a function. So I'm looking for the one that repeats. -8, 2, -3, and 4. Does that repeat? No, that is a function. -2, -5, 3, and 6. Did that repeat? No, so that is a function. 7, 6, -1, and 6. Did that repeat? Yes, so the 6's are repeating. So because x is repeating, that is not a function. Be very careful what the question is reading. So this is saying which one is not a function, the one that repeats. Now you can do this from a coordinate, or you can also do it from a graph. So looking from a graph, x cannot repeat. The easiest and quickest way to do this is just by looking at the vertical line test. And that what that means is when you draw a vertical line, if it goes through 2 points vertically, x is repeating. Why? Because if I was to write the coordinate here, this would be -2, -1. This one here would be -2, +1. And we just did this question, x cannot do what? Repeat. So if you draw a vertical line and it goes through two parts of the graph, it is not a function. All right, so this one is not a function. All right, plot points and the exponential. So they give you this table and they ask you what the isotope is. All right, so the isotope of any exponential function, as a matter of fact, I'm going to do the isotope and the y-intercept so that we case you need that later. All you need to know about an exponential function is it's in this form, and sometimes there is a c on this, right? So you can see that this written in this form will be this. All right, so you can see there's nothing here, and when we don't have anything there, we can put an invisible 1. So a is 1, b is 2, the x is the x, and c is -2, right? All right, so all you need to know is the isotope is c. So c is the isotope. So c is the isotope. All right, then a plus c is the y-intercept. Okay, so what does that mean? That means I take whatever a is, I add it to c, and that's going to give me the y-intercept. So a is 1 minus 2, that's going to give me the y-intercept. So 1 minus 2 is going to be -1. So when I see x is 0, I should see y equals -1. So let's find 0. Yep, here we go. And the y-intercept is what I expected. So the y-intercept is -1, and the isotope is just this number right here too. Now be careful, because if a graph is shifted or translated in any way, obviously the y-intercept rule will change. For example, if you have, instead of this equation here, let's say we had a +2 here. I am shifting, okay, I'm shifting this exponential function, so it's going to change my y-intercept from being at -1. Okay, so just a quick note, and I'll show you that in an example. So let's do this question. My original problem. Here's my question. You see it's shifted, right? So I would think my y-intercept will be 1 minus 1, which is 0. But you can see here it's not 0. Why? Because this graph has been shifted right here. So it is not quite 0 minus, it's not, the y-intercept's not at 0 because this graph is shifted. For it to be at 0, you have to have it in this format: a, b, only x plus c. Okay, but that's, regardless, it doesn't matter. All I need is the isotope. The isotope is -1, so -1. And then you're going to go ahead and plot each of those points. All right, so you don't want to find the ones with, like, this 255 is way over the graph. You want to find the one that has from -10 to +10 and no decimals or fractions or anything like that, like whole numbers. So 63, 35, 15 here. -5 and 7, I can do that one. So -5 and +7, -4 and +3, -4 and +3, -3 and 1, -3 and 1. And notice I'm going x and then y, right? -2 in the x direction, 0 in the y. So -2 in the x, 0 in the y. I can't do that one because it's halfway. I might get that wrong. And all of these are decimals. How many points do I need? 1, 2, 3, 4, and I need 4. Okay, cool. So once I have 4 points, that's enough. All right, then you're going to do what? Press next. Draw a function with your mouse through all of your points. Now, the big thing about this, when you're drawing the function, it's going to, do all kinds of things, right? But when you come to the isotope, do not cross the isotope. Do not touch the isotope. Don't do that. Do not also do this, like where you're just coming right down here, okay? Don't do that. So just make sure that when you're drawing your line, go through the points as best as you can. And when you get here, gradually draw your line. I don't know if that will accept since I did this little up thing here, but we're going to try it out. So again, gradually fall down. Don't immediately go from here down to the line. So gradually taper it off, okay? And just don't touch the line. Let's see if it'll let me go get away with that. It did. So it's very forgiving. Just the biggest point is just make sure you hit all your points. I'm all over the place, but it's fine. Just hit all your points, and then over here, gradually come to the isotope, and you'll be okay. All right, so transformations. All right, so there is quite a few things I need to say about transformations before we can even start looking at the question. All right, so I'm just going to write some notes for you. This is, of course, in your notebook. We have covered this several times. X is opposite and inside. Y is outside, and regular. All right, so basically, if it has to do with the x, it's going to be inside the function and opposite of what you think. If it's the y, it's outside and what you think. All right, then the rules for this are as follows. So there are 3 rules. Number 1, if you're adding or subtracting, it is a shift, meaning it's a movement, left, right, up, down. So left, right is X, up, down is Y. So if you are multiplying, okay, you are stretching, stretch. There are 2 ways you can stretch. There's a fraction. So if I multiply something by a fraction, it makes it smaller. Now, this is a fraction that's smaller than 1. So that's different from 3 over 2 because that's bigger than 1. So that's actually going to make it larger, so smaller. So this is going to make it larger. So if it's a fraction bigger than 1 or an integer or a whole number like, let's say 3, all right, it makes it larger. And then number 3 is if you have a negative, if you're multiplying by a negative, it is a flip or a reflection. And the thing that I need to really emphasize with this is this flip or reflection is the only exception to our rule. This one is opposite whether it's inside or outside. Opposite if inside or outside. All right, so these are the rules that you need to remember once you figure out if it's inside or outside. So let's actually do a question, right? All right, so we have a graph for x squared. So x squared is the function. So if it's inside, it will be inside the square. If it's outside, it will be outside the square. That's what that means, okay? If the function was something else, like let's say square root of x, okay? That means if it's inside, it will be inside the square root, like that's inside. If it's outside, it'll be outside the square root. So inside and outside just depends on what the function is, but you put the function acts as the parentheses. All right, so in this case, we see that the function, actually, I'm just going to work from the answers real quick. All right, I'll start with this one right here. Is this inside the function, inside the parentheses, or outside? Hopefully you can see that's inside, so you go to inside. If it's inside, it is your x direction and opposite of what you think. And because this is adding and subtracting, it is a shift. So let's talk about that. If you're going to shift in the x direction, okay, so I'm going to draw a line. Here's the x direction, this way and this way. If you're shifting in the x direction in -3, which way are you going? To the left, right? But remember, x is going to be opposite of what you think. So instead of it shifting to the left, it's really shifting to the right. So that's what this means. This means right 3. Okay, that's what that means. All right, now if we're looking at, I'm going to go ahead and erase that. All right, we're going to look at this +4. I'll do a different color just so we can highlight it. This +4 right here. Is that inside or outside? That's outside. So we go to outside. Outside is y and regular, what you think. So if I think of y direction, adding 4. So remember, adding and subtracting are shifts, right? If I think of the y-axis, if I'm adding, I'm going up. If I'm subtracting, I'm going down. So this one is going up. And again, it's what you think because it says it's regular, right? So this is actually up 4. And what you're asking yourself is, the graph is a solid black line. Did it go right 3 and up 4? So here we go, right here. So this point, I'm going to go the vertex to the vertex. I'm going to go right 3 and up 4. It just so happens that the very first one that I checked is what the answer is. All right, but I am going to go through the explanations just because depending on which kind of question you have, right? So those are shifts, is plus and minus, and all of these are shifts. I'm going to now look at, I'm just going to add some stuff actually on this so we can just make it simpler. All right, let me look at stretches. So let's say I have a half over here. All right, so I'm just adding this question. If I have a half over there, is it inside? Is it inside the parentheses or outside? It's outside. So it's outside, it's going to be y. So it's going to be in the y direction, okay, in the y direction. And then it's going to be what you think. So what does a half do? So you come right here. A half makes it smaller. Even if it doesn't matter what the fraction is. If the fraction is a third, a fifth, an eighth, as long as it's smaller than 1, it makes it smaller. If it's a whole number or a fraction greater than 1, it makes it larger. So if it's shrinking in the y direction, shrinking means it's doing this, right? It's shrinking, all right? Coming down, shrinking. And if you imagine squashing something, and I don't have anything I can really squash, if you squash something like this, you're actually making it wider, okay? So if I try to squash this from both directions, because I'm shrinking it, it's going to become more of a bowl, right? Than, you know, It's going to become a wider graph, just so that you know, just an FYI. All right, and then the last thing I'm going to talk about is if it's a flip. So let me put a negative outside, and here I'm going to put a negative inside. Okay, so what are negatives? Negatives are flips or reflections, and they're opposite whether they're inside or outside. So let's take a look at this one. If it's outside, I think it has to do with the y, but it's opposite no matter what I think, so it's really flipping over the x. If it's inside, right, inside is supposed to be x and opposite, right? So opposite of what I think, so inside is supposed to be x, so opposite will be flip over the y. Now I'll just do a couple of examples just without the notes, just so that I can see what we can go over. Okay, so here's, oh, perfect, here's some stuff. All right, so I can see that automatically it's flipped. It's flipped over the x, right? So remember, I need to see a negative somewhere. Now the question is, do I see it outside or inside, right? So let's go over it. If it's negative outside, I would think it's y and regular, but negatives are opposite no matter where they are. So it's really flip over the x. So it needs to be on the outside in order to flip over the x. So the only two options are these two. All right, so now once the graph has been flipped, so it looks like it's over here, what are we going to do to it, right? So we're going to move to the right 2. If we're moving to the right, that's in the x direction. So in order for something to be x, it has to be inside, right? So I need something inside. So both of them are inside because it has to do with the x. Now the question is, how do I say right 2? So remember, inside is x and opposite. So I would think right 2 would be plus 2, but because it's opposite of what I think, instead of plus 2, it's really minus 2. Okay, and that's the process. So let me do another example. So here's another one. All right, so here's another example. There are no shifts, so there should be no negatives. What do I do here? I went left 2, up 5. So remember, left, I would think, because it's going in the x direction, left would be minus 2, but it's opposite, so I'm looking for plus 2 inside. So it's either this one or this one. And then I went up 5. That means y and regular, so whatever I think. So which one would it be? Minus 5 would be going down, plus 5 will be going up. So when you get really good at the rules, you can do this really quickly, okay? I'll do one more. Again, this is a reflection over the x, so I'm looking for a negative inside or outside, right? Because it's reflected over the x, I would think that it's inside because x is inside and opposite. But remember, negatives are opposite no matter where you are. So it's really going to be outside. So it's either one of these two. So this will be reflected over the x-axis. This will be reflected over the y-axis. So one of these two is going to reflect it, and I'm looking to move it to the 4 left, right? So if I'm moving in the x direction, remember x is inside and opposite, so it's going to be opposite of what I think. So if I think go left 4, I'm going to think minus 4. Opposite of that would be plus 4. Okay, so once again, once you get really good at these rules, and you might need to just see me real quick so I can set you up with, just like a few problems with how to do it, just so you can get real good with it. It's because it's really simple once you understand it. All right, so stretch and compressing functions. This is the same thing as we've been talking about. So multiplication, whole number or fraction greater than 1 makes it stretch. A fraction less than 1 will shrink it. Inside and outside rules still apply. So for example, this is outside. So remember, outside is y and regular, right? So what does a whole number do? It stretches it. Because it's outside, it's in the y direction, so it stretches, so it pulls up. And if you were thinking about this, if you pulled the graph up, it's going to become narrower. So just a good idea to know just for multiple choice. But in this case, I'm going to stretch it in the y direction by a scale factor of 2. So I look at my y values. I got 1 here. I can take this dot and stretch it by 2, which means multiply by 2, so it'll become 2. Or I can take this dot right here, which is at 4, stretch it by 2, which will become 8. It doesn't matter which point. So I'm going to take this one, times 2 in the y direction, stretch it. Do you see how it became narrower? And my 4, the point that was at 4 now went to 8. Okay, so stretching and shrinking. Outside is y and regular, inside is x and opposite. So if I had this on the inside, instead of it being a stretch, it'll be opposite, so it'll be a shrink. All right, so we'll do a couple of these. I see I have 2 chances, so we'll do a couple of them just to make sure you understand them. All right, so this is good. Inside or outside? This is outside. It is a fraction less than 1, so it's going to do what? Shrink. Because it's outside, it's in the y direction, and it's regular. So shrink in the y direction. That means I take any of these points, doesn't matter which one, and I shrink it by a half, by a scale factor of a half. So if I look at this number 4, if I take this point right here, it'll go from 4, If I take half of 4, I'll get 2. So this dot right here is going to move to 2. Or I can take this dot right here. Try to stay away from things like 9. Half of 9 is 4.5. So me trying to get it exactly in 4.5, I may be wrong. So stay away from like decimals. Even 1, shrinking that by half will give me to 0.5. So that will be a decimal. So stay away from decimals. Let's work with whole numbers. So the only point I can really use is this 4. So in the y direction, I start at 4. I shrink it by half. This point 4 is going to go right down to 2. And what does that do? It makes the graph wider. So kind of keep an eye on that. So I have points. Again, I'm just going to do a few just to make sure. All right. So it doesn't matter what the graph looks like. So this is the function 2 to the x, right? What am I going to do? I'm going to shrink it by 1/8. Why am I shrinking? Because this is still outside the function. So pick any number that can shrink by 8. I'm going to pick this because this is 8. It's outside, so it's y and regular. So this point right here is going to shrink by 1/8. So 8 divided by 8 comes down to 1. So you draw it right down to 1, and you put it right on 1. Now, I'm not going to get that right because then I won't get any more examples. So I want to make sure I get examples. But you can see it comes right down there. All right, next problem. Again, this is a stretch in the, it's outside, so it's y and regular, so it stretches by 4. So if it starts off at 2, this point times 4 will go to 8. So I go up to 8. I'm trying to find some that are on the inside. Let me find some examples. Anything on the inside, these are all outside. It doesn't look like they have anything on the inside, right? Remember, inside will be within, like, okay, let me assume this one is. All right, so on the inside, you'd have parentheses here, and then it will be inside the parentheses. But this is all on the outside. So let me do an example for, one of the functions that we're going to see like this. All right, let me assume that instead of that, it's actually inside the parentheses, so it's parentheses. So this will mean if there was a parenthesis there, in other words, it looked like, and I don't have anywhere to write this, but it looked like this, 4x parentheses, then squared, like that. So it's inside the parentheses, all right? Inside the parentheses will be x and opposite. So opposite of whatever you think in the x direction. So positive 4, you would think multiplying by 4 is going to make it bigger, but because this is x, it's opposite, so it'll make it smaller by a scale factor of 4. That means now you're looking at the x-axis and dividing it by 4. Okay, so 1 will be by a 4th. There isn't a good number here, unfortunately, in our example. 2 would again shrink in the x direction, so it will go, this will be half, this will be a 4th like right here, so you'd move this point, and again, because we don't have whole points, it'll do that if it was in the x direction. But this is on the outside, so I'm going to start over. This is a stretch in the y direction, so every point moves by times 4, so 1 is going to go to 4. All right, so it looks like all of these are about it being on the outside. So we'll do one more. So again, this is on the outside, y and regular, so it's going to shrink by 1/4. So every point on the y, because it's on the outside, is going to shrink by 1/4. So if it's at 8 and it shrinks by 1/4, 8 divided by 4 will give me 2, so I come right down to 2. All right, so it goes from 8 to 2, shrinking. All right, and that's pretty much it. Linear inequality systems graphically. So we've already talked about how to graph in y equals mx plus b, so this is just a quick refresher. Really, where our focus is what does this mean and what does that mean? All right, so I'm just going to graph real quick. Remember, when it's in y equals mx plus b, you start with the y-intercept. So right now, the y-intercept is 2, so 2. And then what does this do? What is that slope doing? Remember, you put an invisible 1 on top and on the bottom, so it goes down 1, right 1. So down 1, right 1. All right, now, because it is, and I should actually pick a different example. Because there's a solid line underneath, this is a solid line. So if it didn't have this less than or equal to, it just had less than, then I would change it to a dotted. So very, very important that you have that. So right now it's solid. Now, remember, and I'm going to actually do it this way so that I can make sure that you understand this part. All right, so remember, this is what? Small, right? This is big. So this is y is small. So where do you see small values for y? So here's the y. Look at the values. Where do you see the small ones? The small ones are negative, right? So that means that you're shading this area here. All right, so because it says y small, you shade the small ones for y to the line. When it says y big, you would go to the big numbers for y and shade to the line. All right, so I'm going to put that in there. So let's see, can I change shade? Boom. See that? I've just graphed the first one. Now I'm going to go and graph this one. Okay, so again, I start at -4. So I start at -4. And what does this tell me to do? This goes up 1, right 2. So up 1, right 2. All right, again, is the line solid or dotted? It's solid because it has the line underneath. And how many do I have? So I'll get this one wrong. So it's dotted because it has a line solid because it has a line underneath. But now I'm going to shade where? I'm going to shade big, right? So I'm going to shade up. So this second line is somewhere over here, and I'm not being exact, right? This is the line right here, and it's y big. So here are my big values, and I'm going to shade from my big values to the line. Big values to the line. And the question is, where do you see both the purple and the blue? It's in this section here. So the overlap is your answer. So my overlap is going to be, let me change shade. Oh, you shade both. Okay, cool. This is cool. All right, so you shade both, right? And my overlap, so this is big, right? Just like we just did. The overlap is in here. So the question is, where is a solution? So now, here is something very, very important. A solution is anything on either line because it's solid. If it was dotted, then no. So we're used to going to the solution being 4, -2, which in this case works. But if this was a dotted line, this would not be a solution, okay? So just so that we are on the same page, whenever you are doing the shading, the inequality, just pick anything in here, like completely away from the line so that you don't make that mistake. So remember, the dotted line does not include it. All right, I'm going to get this one wrong just so that I can do another one. So you see, any point in here will get you right, anything in here. Let me pick one. Yes, this is a good one. So, because I have one that's solid and one that's dotted. All right, so I'm going to go a little bit faster. So again, graph the equation. So 4, and then you're going 1 up, right 6. 1 up and right 6. All right, solid or dotted? Solid because it has a line underneath. Y is what? Big. So y is big. Where are the big values? Up here. So there you go, shaded. All right, now I go to this one, -5. So -5. And then I'm going to go 4 down, because it's -4, 4 down, so 4 down, 1, 2, 3, 4, and right 3, 1, 2, 3. And again, is it open or closed? It's open, so this is what I was talking about, that dotted line. All right, so dotted line, and then it's y small, so small values of y. So where are my small values of y? They're not here because this green is on big, so change the shade because small is right here. Now your intersection of shades are your solution. So remember we talked about it. If you put this as an answer, it's going to mark it wrong. So if I put -6 and what's this, 3, I'm going to get this question wrong, and I'll prove it to you. Boom. This is incorrect. Why? Because this is not a solution because one of the lines is dotted. So I can pick a solution here, anywhere here on this solid line, or anything on the inside. So again, just go on the inside. So let me pick -9 and 4. All right, so -9 and 4. And we should be good to go. All right, so relatively simple. Just stay away from dotted lines. All right, so there are plenty of ways that you could do this kind of question. You are more than welcome to do it whichever method you please. I'm just going to focus on the X game. So you can use a quadratic formula and work backwards. You can use the area model, whichever method that you please. For me, I'm going to use the X game. All right, so first of all, I need everything equals 0. So I need everything to go to the other side. So I'm going to take this to the other side. It's going to change from -x to +x. I'm going to take this to the other side. It's going to change from -8 to +8. All right, let's go ahead and combine what we have. So I lined them up with what goes with each other. So this is 4x squared. Negatives meet positives. They're going to fight. Who's going to win? Nobody. So that's going to be +0x. And I'll leave that in there for right now. Then I've got negatives are meeting positives. Who's going to win? Negatives are going to win because I have more people. By how many? 1. All right, so this is my new equation, right? So whenever I'm solving a quadratic equation like this, and I'm going to leave the 0x in there because that's important. All right, I'm going to create my X game. So my X game says, all right, you multiply A and C and you add to B. That's what it says. So A and C, so this multiplied together is -4. Make sure you keep the sign. And it adds to 0. Okay, so still very important. So I need to find two numbers that multiply to 4 and add to 0. So I start listing them out. 1 times 4, 2 times, and remember, you could do this with our pizza slices, right? I can take half of that, so that'll be 2. I can take half of that again, so that will give me the answer for 4, so that's going to be 1, and so forth, right? And I'm looking for the one where if I manipulate the signs, I'm going to get a 0. All right, so looking at this, 4 plus 1, 4 minus 1, will that give me 0? No. All right, so I look at the next one, 2 plus 2 or 2 minus 2, would that give me a 0? Yes, 2 minus 2 will give me a 0, right? So I'm going to try that out. So it'll be 2 minus 2. That's going to give me a 0, but it also has to multiply to this. 2 times -2, is that -4? It is, so this works out as that's the sign. All right, so once I got my two numbers, these are my factors, I'm going to divide. My next step is to divide both by A, which is 4. All right, simplify, always, 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 always simplify. So what goes into 2 and 4? 2. 2 goes how many times? 1 time. And into 4, 2 times. And this is going to be the same thing, only it's going to be negative. All right, now remember, when you have a fraction, the way you write it is that the denominator goes in front of the x and the numerator stays where it is. So put in the denominator in front of x, you'll write this as 2x, right? And then positive 1. This one, denominator in front of the x, 2x minus 1. Okay, so these are my factors. Now, I can solve for 0, and I'm going to check what the question was asking me for. Oh, it'll solve. Okay, so maybe it might be faster for you to do the quadratic formula. It doesn't matter. But for me, I still like the x game. All right, solve means I need x equals two different numbers. So remember, we talked about the shortcut. So I'm going to first do the shortcut, then I'm going to show you why. The shortcut is the solutions are this, but opposite answers. So if it's positive a half here, it'll be negative a half. If it's negative a half here, it'll be positive a half. And of course, I can prove that by doing this. Okay, so 2x plus 1 equals 0. And over here, I have 2x minus 1 equals 0. Okay, and you can solve it. So I'm going to take this to the other side. That's going to be minus 1. So it's going to give me 2x equals minus 1. Divide both sides by 2. So there I have it. X is equal to 1/2. That's that one. Come right here. Take this to the other side. That's plus 1. So I have 2x equals 1. Divide both sides by 2. And there I have it. X equals 1/2. Okay, so again, you can actually solve this out, or you can realize that your factors are your answers. Just change the signs. Okay, I'm going to do a different question because that was, I think, a little bit easier. So let me get this one wrong. Let me see if I can find one that's a little bit like higher. So this is 1/5 and 7th. Okay, these numbers are a little bit bigger. But the factors are easy. Does this look complicated, maybe? Well, okay, let's do this one. Let's see. All right, so this is my original question. All right, so again, everything has to be equal to 0. So we're going to take this to the other side. So negative changes to positive 5x. That's gone. This goes to the other side, changes from positive to negative. That's gone. Okay, combine like terms. So you have 4x squared. And then you have negatives are meeting positives. Negatives are going to win by 8. And then negatives are meeting positives. Positives are going to win by 3 equals 0. So once I have it as a quadratic equation in standard form, so equals to 0, remember your x game says you multiply to AC and you add to B. So multiply AC, so 4 times 3, which is 12, and you keep the signs, and you multiply to negative 8. All right, so I need two numbers that multiply to 12 and add to negative 8. So 1 times 12. All right, so again, remember you can take half of 12, so that's going to be 6. I can take half of 6, which will give me my answer for 4, which will be 3. I can't take half of 3 anymore, so that means 8 is bust. All right, once I kind of finish a cycle, like check. 1 plus 12 or 12 minus 1, is that going to give me 8? No. What about 2 and 6? Yes, 2 plus 6 is going to give me 8, and I can mess with the signs, right? So let's try that. And this does not necessarily mean that it's going to work. We're just trying it. All right, so what do I need in order to get negatives? I need negatives. I'm meeting negatives, so there can be more negatives. Now, does this give me 12? Negative 2 times negative 6. Does that give me 12? It does. So this is actually what's going to work. My last step is to divide by a, which is 4, and then simplify. So we're going to simplify this. What goes into 2 and 4? 2 goes 1 time, and that's negative, and 2 goes into 4 2 times. What about here? What goes into 6 and into 4? 2 also. So that's going to be negative 3 times, and 2 into 4 is 2 times. Can I do it anymore? No. Anytime you have a fraction, so remember the denominator goes to the front. So this is going to be 2x minus the 1. And on this one, denominator to the front, so 2x minus the 3. Okay, that's how you write it out in factor form. Again, you can write this all out, or you can remember that the answer is just x equals your answers but opposite. So that's going to be positive 1/2, and opposite of negative 3 over 2 is positive 3 over 2. So this will be it in factored form, and this will be it if it's solved. So if the question was solved, which it is, it should be 1/2 and 3 over 2. Boom. Okay. All right, elimination. I put this as guided because it might have been a while since you've done this. So solve the systems of equations by completing the squares, completing each step. There we go. All right, so remember, for it to eliminate, you have to have the same x's but opposite, or the same y's but opposite. So it doesn't matter which one you choose. So is it easier to get, so these are already opposite of each other. Is it easier to get 2 to become 6 or 1 to become 6? Again, your choice doesn't matter. I'm going to pick the lesser number because it's easier. I can multiply this by 3 and it's going to become 6, right? So if I come right here and I say times 3, and automatically, see what it did? It multiplied each one by 3. So you multiply this by 3, this by 3, this by 3, everything by 3. Don't forget even this last one. All right, do I need to multiply any of this? Because now it's become 6 minus 6, which is going to eliminate. So no. So I'm going to put invisible 1 there, because now it's already eliminated. I can see 6 minus 6 will give me 0. Negatives are made in positives are going to fight. Positives are going to win by 3. And then here, negatives are made in positives. Negatives, they're going to fight. Negatives are going to lose. So positives are going to win by 12. All right, and you're going to try it. And if you're wrong, that's fine. You're just going to do it again. And that way you know exactly what point of the step you're wrong. All right, then you're going to solve for y. So I divide both sides by 3. So 12 divided by 3 is going to give me 4. And again, you're going to try it. All right, if you're right, it keeps going. If you're wrong, you're going to do it again. All right, so plug in into whichever one of these questions that you want. You're going to plug in 4. So I'm going to choose this one because the numbers are smaller. So I'm going to take this right here. And I wonder if it's going to let me show the work here. Hey! All right, so I'm going to put it there because I want to plug in, what am I plugging? 4 for y, right? So where I see y, I'm going to put 4 in parentheses. So I've got 2x minus 4, okay, which is going to be just minus 4, equals 16. And I'm just going to work out of here. What am I going to do to both sides? I'm going to add 4. I'm taking this to the other side, so this is plus 4. All right, and I'm going to get rid of that because that's gone. This is going to be 16 plus 4, which is what? 20. All right, then I'm going to divide both sides by 2. So I'm going to divide this side by 2 and divide this side by 2, which is going to give me 10. Now I'm ready to try my answer, so I'm going to get rid of the x equals. And I'm going to try. Hey, that's right. So now put in my final solution as a coordinate x and then y. So I'm going to put in 10, and then I'm going to put in 4. Now again, I'm going to get this question wrong because I want to try another one. Oh, it's 2 questions, so I can get it right. Okay, so try. If this doesn't stop you, then you are good to go. Okay, so I'm just going to do another one just to make sure. So again, elimination is to get these numbers to be the same but opposite. So either the x's or the y's. So again, looking, what's easier? It's easier to get this y to be 2 than it is to... Actually, I'm going to do both. How about that? I'm going to show you that you can do whichever one you want. I'm going to make 4 and 5 the same number but opposite. Okay, so I'm going to keep doing it until I get it here. What happens if I multiply this by 5? Oh, by 5. Okay, so that's going to make that 20. How do I make this one 20? If I multiply it by 4. So remember, you're multiplying everything inside. So you see, I've multiplied. But this isn't going to get rid of it because I need them to be opposite, right? So I'm going to make this negative 4. Now they're opposite. X is gotten rid of. But my numbers are bigger than they would have been if I had just multiplied it by 2 right here. which I'm going to show you that you can. So that's how I'm getting rid of the x, right? But what if I was getting rid of the y? So instead of doing that, I would multiply this bottom one by 2. And you see already, I'm getting rid of the y right here. So that means I multiply that by 1. Those numbers are smaller, but your choice is up to you. So I'm going to put the x's back. Just, what did I get the last time? Oh, yeah, I'm going to do it by y's because the last time I did x's. So, again, once they're the same but opposite of each other, whether it's x or y, doesn't matter, you're good to go. All right, negatives are made in negatives, more negatives, so negative 14. Negatives are made in positives, but they're going to both lose, so 0. 0 is made in negative 28, so negative 28. And then we're going to try. Hey, if you're good to go. Divide both sides by negative 14. So a negative divided by a negative is a positive. 28 divided by 14 is 2. Again, we're just trying. Plug in 2 to any one of these. It doesn't really matter because nothing is really simple, but I'm going to do this one because this one looks the most simple. Again, doesn't matter which one you pick. All right, now all right, so I'm just going to plug in x is equal to 2. So where I see x, I'm going to put 2. All right, then work it out. Negative 5 times 2 is negative 10. Take the negative 10 to the other side. It's going to be positive 10 on the other side. All right, negative 14. So negatives are meet in positives. Negatives are going to win by 4. And so my y value is equal to 4, negative 4. All right, so what's my final coordinate? X and then y. So x is equal to 2, y is equal to negative 4. Try, submit. Yes, I'm sure. Perfect. All right, last one, evaluate quadratic functions. So you're just plugging in, again, remember this is just like the first one where you see x, put in 5. So we're going to take this, and where I see x, so I'm just going to show you the work here. Where I see x, I'm going to put in 5. And this is an x squared. All right, so let me fix the squared first. So this is a squared, so I don't forget. And where I see the x, I'm putting in parentheses, and I'm putting a 5. Here's another x right here. So again, where I see an x, I'm putting in 5. So the thing about evaluating functions is you have to look at it. So f of x, and this is f of 5. So this means when x is equal to 5. So everywhere I see x, I put in 5. Well, let's work it out one step at a time. So please excuse my dear Aunt Sally, exponents first. All right, not that negative, just the exponents. So 5 squared, that's going to be 25. And notice that negative stays outside. All right, multiplication, please excuse my dear. So multiplication and division in order. So negative 3 times 5 is negative 15. All right, then adding and subtracting. So I have negatives, I made in negatives. That's going to be more negatives, so negative 30, 40. And then finally, I have negatives, I made in positives. Who's going to win? Negatives are going to win by 20. And that's all you're doing. So evaluate just means substituting it in. Okay. Shall I do one more? I guess I can do one more. Let me do a negative one. All right. Again, I'm going to substitute where I see x, and I'm going to replace that with a squared. Where I see x, I'm just going to put in parentheses negative 6. That's what that means. Everywhere I see x, I only see it once. All right, let's work it out. Exponents first. So negative 6 squared is going to be positive 36. I'm going to put that in parentheses as well. All right, then we're going to multiply this next. So negative 2 times 36, that's 60. That's negative 72. And again, you can do this with paper. Negatives are made in positives. Who's going to win? Negatives are going to win by 70.